Today we're going to be talking about trig ratios and finding angles. Our objective is that we will be able to show the relationship between angles and sides of a right triangle using the sine, cosine, and tangent ratios. And we will be able to use the inverse trig ratios to solve for unknown angles in a right triangle. So first, trigonometry is the study of the relationships between the sides and the angles in a right triangle. So given the following right triangle, find the sine of x, cosine of x, and tangent of x. So given that this is angle x, the side across from that will be our opposite side. The side across from the right angle is always the hypotenuse. And the third side that's touching the angle but not the hypotenuse is the adjacent side. Sine of x will always be the opposite side over the hypotenuse. Cosine of x is always the adjacent side over the hypotenuse. And then tangent of x is the opposite side over the adjacent side. A way to help you remember this is the phrase so ka toa. So ka toa. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Let's try it out for some numbers. Before we can find our ratios, we need to label the sides of our triangle. Since it's asking for angle D, we're going to go from angle D, and we're going to go straight across, and that's our opposite side. We're going to go straight across from the right angle. That's our hypotenuse, which leaves this side to be our adjacent. So remember, sine is opposite over hypotenuse, so it would be 3 over 5. Cosine is adjacent over hypotenuse, so it would be 4 over 5. And tangent is opposite over adjacent, so 3 over 4. What if it asks us for these ratios for angle F? If you notice, this is the same triangle we had before, but we're using a different acute angle. So now we're up here at F. So straight across from it, that makes this the opposite side. Across from the right angle, still the hypotenuse. And that leaves this side to be the adjacent side this time. So sine is opposite over hypotenuse, 4 over 5. Cosine is adjacent over hypotenuse, so 3 over 5. And tangent is opposite over adjacent, which is 4 over 3. We can use these ratios along with our calculator to find angles in a triangle if we don't know them. So we do this using the inverse trig functions, which are sine inverse, cosine inverse, and tangent inverse. They have that little -1 exponent. That means inverse. So the way to undo tangent is tangent inverse. So A would equal the tangent inverse of 1.73. Now, important things are one, that our calculator must be in degree mode. So let's look at our calculator. If I push the mode button, that's up here next to second, it's hard to see, but down here next to radian, it says degree. We need to go down and put it on degree mode. And I can push second mode to quit. Now, if I type in tangent inverse, which is second tangent of 1.73, I get this big long decimal. Now let's look and see what they asked us to round to. It says find the measure of angle A to the nearest degree. That means the same thing as the nearest whole number, so this would round to 60 degrees. Same idea if we have cosine of A. A would equal cosine inverse of 31 over 50. Let's put that in the calculator. Second cosine 31 over 50. And that would round up to 52 degrees. Again, we're looking for the measure of angle A. So we're going to label the pieces of our triangle, go straight across. That's our opposite side. Across from the right angle is the hypotenuse, which leaves this to be the adjacent side. Since we're given the opposite and given the adjacent, that means we want to use tangent, because if we look back, our tangent ratio was the one that used opposite and adjacent. So, tangent of A would equal 5 over 5, which we could simplify to 1 if you wanted, or you could also do that A equals tangent inverse of 5 over 5, or tangent inverse of 1. It'll give us the same answer. It gives us that angle A is 45 degrees. Our final example is a word problem. So you are standing 350 feet away from a skyscraper. So that's this distance here. If you can want, you can draw that you're standing over here. From a skyscraper that is 750 feet tall. What is the angle of elevation from you to the top of the building? So angle of elevation means that when you're going from the ground and going up like that. So if we go across from us, this is our opposite side. This would be the right angle. So our hypotenuse would be over here, and that leaves this to be our adjacent side. So again, we know adjacent and we know opposite. So that's our tangent for TOA. So tangent of x equals 750 over 350. So x is equal to tangent inverse of 750 over 350. So x would equal, let's put it in our calculator, tangent inverse of 750 over 350. And it didn't tell us what we're rounding to, so let's do 2 decimal places. 64.98 degrees. That's all for today. Fill out your summary and I'll